Okay, let's get started. Thank you guys for coming. Wow, what a great crowd. This is terrific. For our 15th Markesbery Symposium. Can you believe it's been 15 years already? Terrific. So I'm Linda Van Eldik. I'm the director of Sanders Brown Center on Aging and the Alzheimer's Disease Center at UK. And I'm the host of this meeting, so I get to introduce all the great speakers today. And I just wanted to have a few business items before we get going. So when you got your program, you should have gotten a little index card along with it. That is for you to ask questions of the speakers. So if you have a question that comes up as you're listening to people talk today, be sure to write those down on the card, and we'll collect the cards, I think probably at the break, we'll get the cards. And then we're going to have a Q&A session toward the end of the program, and we'll try to get to as many questions as we can. And then the other thing is, in your program, there's a blue evaluation form. This is really important if you could fill it out as the day goes on, because it's important for us to know what you liked about the program, what you didn't like about the program, and suggestions you might have to improve it for next year. We take your suggestions very seriously when we invite keynote speakers to address various issues. We try to develop topics that you guys are interested in hearing about. So also, we're doing something a little bit different this year. When you give in your evaluation form at the end, you're going to get a little piece of paper with a QR code that's going to let you get out of the parking lot free. So if you want free parking, give this to us at the end. We're going to have a person collecting a box over that door and one over this door. So yeah, I know it's like a little carrot for you, you know? Okay, so without further ado, I am going to introduce the program, and we're going to first have Beth Wells, who is our Philanthropy Council representative. Beth is in the philanthropy department at UK and is helping us to raise funds to support Sanders Brown and support all the great programs that we do. So help me welcome Beth Wells, please.
Thank you, Linda. Thank you all for coming here today. As Linda said, my role is to raise money for Sanders Brown, to do things that federal support does not do. And in this time when federal support is a little more uncertain generally, that's even more important. We are in the middle of a $15 million campaign right now. And I know that there are people in this room who have supported us. There are people in this room who are in research studies, and all of you are taking your time here today to come and learn about the latest research and outlook for treatment of Alzheimer's and other dementias. And it's probably very personal to you. It's very personal to me. We lost my father from Alzheimer's, and several people in the extended family suffered from it. So the reason so thank you all. Thank you for the ways that you contribute even your time to come here and learn today. The kinds of things that are supported through private dollars, mostly through individuals who have a personal family connection or some other reason to want to support research to end Alzheimer's and related dementia. The kinds of things that are supported include research, and many people are not aware that you can give directly to Sanders Brown to support dementia research. And so that's a message that I'm continuing to get out there. We are so fortunate to have one of the best dementia research programs in the country, and one that's known globally right here in Lexington. And one of the things that research support does is help people with the kinds of things that aren't covered, help our researchers with the kind of things that aren't covered in grants. The federal grants have very specific to-do items based on what was submitted. If a new line of inquiry is appealing, if equipment breaks, other kinds of things happen, then private support is very important for that. We also have a lot of incredible outreach programs. I know Dr. Jicha right now is working on one that will be free to primary physicians, primary care physicians, other physicians as well, but mostly focused on primary care physicians to help increase the training, recognition of dementia and understanding of treatment, because that is a real hole in the training of most physicians. So these are the kinds of things that private support does. And I just want to say, if you or someone you know has thought about, when you're considering your gifts to the community at year end, or if you're thinking about leaving money through your will or retirement fund or something like that, if supporting programs that work towards preventing dementia and supporting people who are dealing with it now, whether that be people who have the diseases or caregivers, consider Sanders Brown. And thank you again so much for being here. My contact information is in your program on the opposite side of the agenda for today. But if you think about this later and you don't know where your program is, or you don't remember what to do to reach out to someone, the folks at the Sanders Brown Clinic always know how to reach me. So thank you so much.
Okay, wonderful. So now we're going to be in for a real treat. We have our first keynote speaker. This speaker is from Rush University in Chicago, where I came from. I came from Northwestern in Chicago. So I was really pleased when Julie Schneider accepted my invitation to come today. She is the director of the Rush University Alzheimer's Center, as well as a professor in the departments of pathology and neurological sciences at Rush. She's a very well-known, really excellent researcher, neuropathologist who knows a lot about what's happening in our brains as we get older. And she's going to talk today about that. Her title is Dementia and the Aging Brain, Pathology, Risk, and Keeping Memories Alive. So please help me welcome Julie Schneider.
So, hi, everybody. It's such a pleasure to be here. I am so impressed with your community, with how many people showed up. It's super impressive group of people who want to learn about such a devastating disorder that we all want to do something about. So I'm going to talk about the aging brain, a little bit about risk and keeping memories alive. I apologize. I have to look at least one of the screens. So if I don't look over there enough, I apologize. Oh, no, I pushed the wrong one, I think. I pushed this one instead of that one. Okay, got it. I think I failed my cognitive test already this morning. Okay, so I'm going to tell you a little bit about our studies at the Rush Alzheimer's Disease Center in Chicago. Then I'm going to talk about one of the things we all want to know is our memory loss Alzheimer's disease. We're all worried about our memory. And does memory loss mean you have Alzheimer's disease? So we'll talk a little bit about that. It's not so simple as you might be aware. We'll talk about some other things that cause memory loss. Talk about a diagnosis and treatment, not very much, because I think Dr. Jicha is going to talk a lot more about where we're at with that. Talk about some risk factors and some real resilience to these age-related changes that we all fear. Okay, so what are some of the other causes of memory loss? We all are aware that Alzheimer's disease is related to the slow progression of memory loss in aging. One of the things I'm going to show you is that we actually see a lot more than just Alzheimer's disease in the aging brain. So we see things like vascular disease, and I'll focus on that because I think it's the one that we can prevent the easiest. So it's the one that we can recognize, because we think about vascular disease, we think about our heart, we think about stroke, et cetera, et cetera. And then I'm going to talk about a new disease that we recently recognized with the help of Sanders Brown colleagues. We led a paper on a new entity called LATE, which is a new proteinopathy that we see in the brain when there's not Alzheimer's disease. And we're still learning a lot about this one, and we're excited to have another target for memory loss and aging. Okay, so we study older people in the community. So we're not in the lab looking at mice or other mammals with Alzheimer's. We've cured Alzheimer's in the mouse multiple times. So what we're interested in is what's happening in real people. So at the Rush Alzheimer's Disease Center, we have multiple cohorts, and I'm just going to describe 3 of them here for you. The first is the religious order study. So here we can go across the country and we enroll older people after the age of 65, everybody. We just say, if you're just, want to be in a study, learn about memory loss, we'd like to follow you yearly, do cognitive examinations, do neurologic examinations, and just see what happens in normal aging. Because what happens is a lot of the previous studies in dementia used to wait till someone had dementia. So we would just see what's in the brain of someone with dementia, but what's happening in normal aging. And people really didn't know very much about that. So we started that quite a long time ago. In 1993, I got to Rush in 1996. So I've been involved with that for a very long time. And with the religious order study, we required them to agree to brain donation at the time of death, which is a big ask. And we did a lot of outreach and a lot of teaching to explain, why this is important. Because the people who we've seen, the aging brain has mostly been in people with dementia. So we don't know what the aging brain looks like in people who don't have dementia or various other problems that are happening with aging. So we started that study. It went really well, and we're continuing. That's still ongoing now. But the religious orders are very healthy older people. They live in large groups. They get really good medical care. They all eat a nice diet because they're fed in their cafeterias. And people are like, well, they're not normal older people. You really need to get people who are in the community. So we started the Rush Memory and Aging Project with similar methodologies and a lay population. So we went across Chicago, and I'll show you some pictures, and tried to get the general population from around 40 retirement homes in senior housing, really trying to get a breadth of educational attainment. The religious orders, their average education, they never stop educating themselves. They were going to school even as we were evaluating them. So the Memory and Aging Project, we tried to get a little bit broader range of people, but that's still difficult. The other thing we did with the Memory and Aging Project, which I'm not going to have time to talk about today, but was really exciting, is we started taking spinal cord, nerve, and muscle and looking at motor function. Because another thing that happens when you get older is your motor function declines. And a lot of us don't want that to happen either. And people say, oh, you're just getting old, things are going bad. But we wanted to evaluate that and say, how can we preserve mobility as well as cognition? Finally, it's really hard to enroll minorities. We're not trustworthy as scientists because of our history. And so we recognize that, but we also recognize we don't know anything about older people who aren't white. And that's really a shame, right? We really need to understand the full breadth of what's out there. So in Chicago, we had the opportunity, I'm just showing you one study. We also have a Latino study. This is the Minority Aging Research Study, where we've enrolled now almost 1,000 Black older adults in Chicago, and without dementia at the time of enrollment. And we recruit from senior homes as well as churches and other communities. We build relationships, we give back to the group, we do health fairs with them, and we don't require autopsy. So we try to teach them why it's important to see what's in their brain, but we still want them in the study even if they're not going to agree to brain donation. So this is the religious order study. This is, we have a whole team that goes across the country to visit these different orders. When I first started Rush, I used to do this. It was really fun getting to meet all the nuns, priests, and brothers across the country and doing the cognitive testing. They were very curious about everything we were doing. They sometimes would start studying the night before if they knew we were coming. So this is some examples of the people that we were evaluating. And you can see they live also often communally, and they often have believe it or not, the cemetery is like right next door. So one of the things that happens is when someone dies, sometimes they're on vacation or you move, people move all the time. So the religious order study really gave us an opportunity to get autopsies and get a good representation for autopsies in that cohort. And we have over 90% autopsy rate in that cohort. Okay, so this is in Chicago where we drive around. We have a team of people who are driving to all these different places in Chicago to go see older people in different communities. These are some examples of what they look like. Some of these are quite nice, lesser nice. And then you can see people listening to our presentations. We go just like to a group of you guys and we would say, this is what we're doing in our study. Would you like to join? And this is what we're learning. And this is what you can get out of it. This is what we can, et cetera, et cetera. And they just fill out an interest form. And they say, I'm very interested, I'm not interested, I'm a little interested. So we know if we can contact them again. This is an example of the minority aging research study. And here's the PI, Dr. Lisa Barnes, and they're getting a presentation here. So same sort of thing. We just go to different places to meet people and to tell them what we're doing and see if they want to join our study. So once they enroll, every year we do cognitive testing, we do interviews, we ask them a whole bunch of questions. They really have patience with us because we do ask a lot of questions. We do neurologic exams. They can enroll for MRI. Most of them will enroll for the MRI study and they get results from that. They get results from their blood tests too, so they know if their glucose is high. They'll also know if their blood pressure is high when we do the exam. And we do a lot of other testing every year. We follow all older people, and some of them decline and some don't. And we all know that, right? That some people are declining and others don't. So not everybody ends up with dementia. Indeed, we have over 2,000 autopsies right now. And less than a half of the people who die at about the average age of 90 have dementia. And I mean, the converse is almost half do, which doesn't sound very encouraging, right? So what are we learning about these brains of older people when they die? So one thing we're learning, this is an example of Alzheimer's pathology, what it looks like under the microscope. And it used to be you could only know if you had this pathology if you had a piece of brain tissue and looked under the microscope. You don't see it on an MRI. We do have ways of looking at it now and actually knowing whether you have this pathology in your brain, but I'll tell you why that's good and bad. So here you can see a little bit of this pathology. There's tangles and there's plaques. You've probably seen this on the news. You know, amyloid plaques, neurofibrillary tangles, these accumulate in your brain. They cut off the wiring so you can't, you know, remember things properly, think properly. Almost everybody, not everybody, but almost everybody, I'd say around 80% of older people in the community start developing some of these plaques and tangles as they age. Extremely, extremely common. Tangles are almost in everybody, and plaques in around 80% of people. We diagnose Alzheimer's when you get a lot of these. So people used to think, oh, this is just normal aging. Alzheimer's disease is just normal because we're accumulating it. No, we have a lot of people who never get they get the tangles, but they don't get the plaques. And if you just get the tangles alone, you don't get very sick. You don't have very much memory problem at all. So what happens? This pathology accumulates, but what we've learned over the years is this pathology accumulates over a long period of time. It probably starts in your 50s and 60s where the amyloid starts accumulating in your brain. And it starts accumulating, and if your dementia threshold is here, think of it like your heart. Your heart, if you have a little heart attack, it might not cause a lot of problems. So you might not get a lot of problems if your dementia threshold's here, but here you might start feeling the memory loss. So there's a threshold level at which time you're going to start seeing that there's memory loss if this pathology is accumulating in your brain. Again, very common pathology. But what we see in the brain is not only Alzheimer's disease. What we see when you die as an older person, we see you have a lot of vascular pathology in your brain. And if you remember, it used to be said that dementia was hardening of the arteries. And then everything became Alzheimer's disease. So what was the truth? The truth is somewhere in between, actually. So we started thinking, oh, everything's Alzheimer's disease. But then we started looking at the brains of older people, and we said, excuse me, I'm not sure how to go backwards here. I won't go back then, I guess. Wait, yes, I will. There we go. So what we started seeing is we'll see these tiny little strokes in the brain, ones that might not have been manifested during life because they're so small. And we can see these both under the microscope as well as grossly. Look how tiny that is. So sometimes the MRIs don't pick this up. And we see 50% of our older people who die at the age of around 90 have some of these pathologies in their brain, and that they add to their cognitive impairment and make that threshold go down so they're going to exhibit their Alzheimer's pathology. We also see a lot of vessel disease in the brain. So this is the underside of the brain, and this is atherosclerosis. Around a third of our older people who die at 90 die with moderate to severe atherosclerosis in their, this is called the circle of Willis. These are the big arteries supplying all the blood to the brain. This is a normal one here. So you see that yellow stuff? That's all the calcium, cholesterol. It kind of looks a little bit thickened here, but it also becomes occluded. And this is a normal vessel. You can barely see it. The other thing that happens is these little vessels that are deep in the brain, you see there's blood in the center here, they become thickened in some people, very thickened, and their lumen becomes very narrowed. And this is very common in aging, even more common with hypertension and diabetes, extremely common for these atherosclerosis, arteriolar sclerosis to be increased, as well as having those small little infarcts that I showed you, or strokes. So this is what happened when we first started learning about this. We said, okay, if you have, this is your amount of Alzheimer's pathology, this is your chance of having dementia. As Alzheimer's disease pathology goes up, your odds of having a dementia go up. Makes sense. Pathology is going up, you have a higher risk of dementia. What happens if we see one of these tiny little infarcts in your brain? At every level of Alzheimer's pathology, we found that even if we just see one of those tiny things, that it means that you have an increased risk of having exhibited dementia during life. And kind of surprising, because these were tiny. So we weren't, something we were not certainly expecting it to be that strong of an effect. But it even gets even more complicated, because what happens is, this is if you have, we can see the infarct. It goes up even further if it's under the microscope, only under the microscope, and you can't see it with your eye. And then look what happens. You have around this much Alzheimer's pathology over here. Most people with that amount of Alzheimer's pathology in their brain never get dementia, never. Look what happens if you have different vascular pathologies at that same level of Alzheimer's pathology. So this is if you have atherosclerosis, those small vessels, arteriolar sclerosis. This is if you have infarcts. And now you just went from having around 20% chance of having dementia to around 65 to 70% if you have these pathologies in your brain. So vascular pathology in an older person's brain is bad, and it can look very similar to Alzheimer's, and your doctor might not know that it's really the vascular pathologies that's contributing more than the Alzheimer's pathology. And then just to really push this home to you, how important this is our cohort this is from maybe 8 years ago or so, of people that we called Alzheimer's dementia. So we went out in the community, we evaluated people in the Religious Disorder Study, Memory and Aging Project, et cetera, and we said, with our expert cognitive testing, this person has Alzheimer's disease. And this is what we found for vascular disease in the brain. And so here you can see the red is atherosclerosis. The red, it might be both, I think that is. The blue is atherosclerosis, yellow is arteriolosclerosis, and everything that's cross-hatched here means you had an infarct. So some people get infarcts in their brain without having that vessel disease in their brain. But what do you see here? 75% of the people that we saw in the community who had Alzheimer's disease, we diagnosed with Alzheimer's, also had vascular pathology. So they had a mixed pathology, just not vascular, just not Alzheimer's disease. So I wanted to move on from that, but we have found other pathologies in the brain also that contribute. And I'll talk to you more about why this vascular is so important when I talk about risk factors. But most pathology we see in the aging brain in our autopsy of older people is mixed. It means you don't just have Alzheimer's pathology, you have other things happening in your brain that we need to study more. It's a really exciting time, and you're going to hear more about this from Dr. Jicha, with our ability to see if you have these plaques and tangles during life. And that's really exciting. Nobody ever thought that was going to happen. We have PET scanning you can do where you can see amyloid plaques in the brain now. We have fluid biomarkers. In the spinal fluid we can see, and then just this year, within the past year, there are blood biomarkers for Alzheimer's disease. It means you have a lot of amyloid in your brain, right? So it was just approved, I think last week, one of the ones that was approved, and few months before that. There's biomarkers that will tell you, each and one of you, if you have this pathology in your brain. But the FDA said this is to rule out Alzheimer's disease, not diagnose Alzheimer's disease. So what does that mean? So the FDA is saying, we're not going to give all you guys this test and say you have Alzheimer's disease. If you have cognitive impairment, you have dementia, we'll do the test just to make sure it is Alzheimer's and not something else. Because if it's negative, we need to look for what is it that the problem is. Because often you're going to have this pathology, a lot of it, and not have cognitive impairment. So if you look at 70-year-old people and you do these PET scans or you do these blood tests, 30% of you are going to have positivity on this and be completely normal and never get dementia. So that's kind of a scary thing. I mean, some of you will, but who are those people that are going to decline and get it? And do we do more harm than good if we scare you and tell you, hey, you have this pathology in your brain. We don't know what's going to happen, but this isn't probably good. I'd rather not have it. So it's a tricky test, right? Because it doesn't tell you what's going to happen. So a super exciting time in this era of biomarkers, and we're looking for biomarkers for other pathologies, like these really small infarcts and some of these other things we're seeing in the brain. So I think this is to be continued. There's still a lot of work. I mean, I'm saying within the last year this happened in the blood, which is amazing progress in Alzheimer's disease. It's really super exciting. Okay, so one other thing. So we know now, and you'll hear more from Dr. Jicha, there's a couple of approved Alzheimer's treatments. I'm not sure how many of you are aware of that. They've been controversial because they don't reverse, they just slow the decline a little bit and have some side effects. But if you go to your doctor and you have memory loss, the first thing they're going to do is one of these blood tests, say, make sure, or blood tests or scans, make sure you have amyloid. What if you don't have amyloid? What is it that you have? Well, you could have vascular dementia, like I was just showing you, all those infarcts, and that's what doctors used to think. But we now know there's another pathology in the brain that causes a very similar symptomatology as Alzheimer's. And there's a new name for it. It's called LATE, L-A-T-E. And it stands for limbic predominant age related TDP-43 encephalopathy, which is a big mouthful, I know. Just say late. This was something that we saw pathologically in the brain that was only in another rare disease called frontal temporal dementias. And it was just discovered, now it's getting close to 20 years ago, but originally we thought this protein was just in this very atypical dementia. We now know, and we've been studying for many years, that this pathology accumulates in a lot of older people, just like these amyloids and tau does, and that it's related to a very similar syndrome as Alzheimer's disease. So why is this important? First of all, we think it's a very common reason for memory impairment in aging, in addition to Alzheimer's disease. Under-recognized. Second, it can happen with Alzheimer's pathology. So if you have that and the Alzheimer's pathology, it's, as you'd expect, it's even worse. So this is a graph. This was actually made by Dr. Pete Nelson, who I've worked with a lot on this, this new entity called LATE, and he's here at Sanders Brown, a neuropathologist here. So this is your cognition. This is just a simple graph, and this is time. So let's say you don't have any pathology in your brain. That's all, everything, that's what we want. All of us want no pathology, and we're doing fine. If you have just this TDP pathology late, you're going to get some memory loss, but you're going to decline very slowly. It's not going to be really bad. It's very much in amnesia. I mean, it's still bad because you're still going to have memory loss, but you're not going to get as bad as you would get if you had Alzheimer's disease, which is right here. And then look what happens if you have both Alzheimer's disease and late. So it's really this combination. And so we're learning, why are some people with Alzheimer's kind of chugging along and have this, you know, the same cognition over many years? It's like, oh, they're continuing to do pretty well, versus some that are just really declining fast. And we didn't really know how to predict that. And with biomarkers now, as we learn about biomarkers for these other pathologies, we may be able to predict prognosis better than we can right now for our older people. Okay, so again, I think Dr. Jicha is going to talk about the therapies. There's 2 approved therapies right now, and if you go in to a doctor and you have mild cognitive impairment, or you have what looks like early Alzheimer's disease, there's 2 approved treatments. First, they have to get this blood test or the scan, make sure you have amyloid, and this treatment removes amyloid. You have to get an infusion right now, so it's kind of a big deal. You either have to go every 2 weeks or every month, and there's side effects. The side effects have been scary when they've been published across the country. In general, I think most of us with experience with this have not seen tremendously bad side effects on these drugs. They seem relatively safe, but they do have side effects. And then there's this risk reward. You have to come in, there are some side effects you might get. Is it really worth it? And that's something you need to discuss with your physician if you want to try one of these therapies. What does it do? It removes the amyloid from the brain, and it seems to slow decline by about 1/3. It doesn't reverse anything. It's just going to slow things down a little bit. And we think the earlier and earlier you go, the better it is. So what's exciting is there's ongoing trials across the country to look at this in normal people who are amyloid positive. So those of us, you know, who are sitting around with this amyloid in our brain, what if we started these therapies super early? Would we be able to stave off Alzheimer's disease? And that, the result of that probably won't be out for another couple of years. Okay, so bad news is most of us have pathology in the brain when we die. So this is a graph of people who die without dementia. And everything that's colored here means we've seen pathology in the brain. So very few of us are going to die with very little pathology in our brain. It's just hard to do. Everything that's blue here is Alzheimer's. The pink is vascular, and this yellow-green is more TDP and some other things that we're seeing in the brain. So we know that you can die with a lot of pathology in your brain and have no dementia right up to the time of death, no cognitive impairment right up to the time of death. So we all want to be here. We all want to be resistant to the pathology and not have any pathology in our brain. That would be a goal. But it's also just as important to be resilient to the pathology. And that's how we think a lot of these risk factors are working, is through resilience to the pathology that we know is probably accumulating in our brain. The people we see who die with no dementia, who have pathology in their brain, they have less pathology. They don't have as much amyloid or tau. They don't have as many infarcts. They're not as big. They don't have late as often. So they have less pathology. But they also have other things related to resilience that may not be related to pathology at all. So we look at a bunch of different factors: lifestyle, behavior, medical illnesses, and each of these things I've listed and more are related to resilience. And you can see here, lifestyle, activity, activity, activity. We need to be active late in life. It is so important, not just physical activity, social activity, cognitive activity. All of this is so important. And when we look at these factors in our cohort, it's not related to the pathology. We don't know, it's not decreasing the amount of pathology they have. So we don't really know why somebody with the same level of pathology, if they're cognitively active, are doing better, but they are. We think there's some resilience mechanisms in the brain, but we're really still looking to see what that exactly is. The other thing is diet, and that always comes up. I know most of us are like, oh, we have to eat a good diet again. But we're looking, and I'll show you a couple things, but we're strongly looking at diet at Rush. We give dietary frequency questionnaires and food frequency questionnaires, and we're looking at diet and seeing what is it doing. It doesn't seem that diet is directly, again, related to most of the pathologies, but we don't really understand. Is it lessening inflammation? What is it exactly doing when we eat these healthy diets? Neurobehavior, you probably can do a little bit less about some of these if you're an anxious person or et cetera, but we do find that neurobehavior also can be bad or good, depending on if you're less anxious, if you're less neurotic or depressed, or if you have purpose in life. All those things seem to be a good thing. And then medical illnesses. So the thing I always stress is hypertension. In our cohort, hypertension is related to all the vascular pathologies. Those small infarcts, the atherosclerosis, the arteriolar sclerosis. It's really important, and it's one of those things we all could do something about, is our blood pressure. And it's related to vascular disease in the brain. And it's been shown that both in our group as well as Sanders Brown with Dr. Nelson and Dr. Abner, who you'll hear from later. So really important to keep your blood pressure down. Okay, so risk factors again. So I talked about diet already, social activity, physical activity, blood pressure. Other things that we and others are studying are air pollution. There's multiple studies now showing that the air we breathe affects our cognition. And we have big epidemiologic studies showing that it's true. We don't know why right now, but it's not tremendously surprising. We also are looking at head injury. And though we don't see CTE in the brains of older people, you know, that pathology you see in football players, we do see that people who have repetitive head injuries or just single head injuries do have an increased risk of having some of these age-related pathologies. And we're really looking into that now. Even with falls, with older people who fall, hit their head, we know that that sort of thing might be increasing your risk for dementia too, having small little injuries like that. So just briefly, don't expect you to read this whole thing, but I think you'll get a copy maybe of these slides. There's something called the exposome that we've become very interested in, because everybody knows about the genome, the genes we have, but we have the genes we have, and either we have them or don't have them, and you know, not so much you can do about it once you're here. But we have our environment, and the new word for the environment is the exposome. So the exposome is everything else around us, what we're putting in our body, the air, as you can read here, the air we breathe, the food we eat, the water we drink, the chemicals we ingest, the stress we experience. And we now are trying to measure the exposome and measure these different things. So we have collaborations with multiple people now looking at air pollution, looking at pesticides, looking at the water. And then social environment, how much exercise you're getting, how much sleep. Sleep is a whole separate lecture on the importance of sleep. Alcohol, and our body's response to these things also. So I'm going to end by just telling you about a recent hopeful study that was done by the Alzheimer Association called US Pointer Study. It was a lifestyle intervention study where they had two groups of people. They enrolled normal older people, and one group, both groups they did activities with. They said, okay, this is what we want you to eat, and this is how active we want you to be, and we're going to tell you about your risk factors, just like the lecture I gave today. We're going to tell you all this stuff, and we want you to, we're going to teach you. And then the second group of people got more social activity. So they met with people more frequently. They came in and discussed this. They showed what foods they were eating. So there was a much more interactive and involved group. So they reported their results. It's published now in August at the Alzheimer Association meeting. And the results were both groups, cognition improved. Both of the groups, cognition. And the group that had more interaction, not surprisingly, did even better. So there's something about getting out there, talking to people, doing this, as well as the activities themselves. So activities themselves helped, but it was even more when it was a socially involved activity. So this is from the US Pointer study saying what you need. They recommended physical exercise, 30 to 35 minutes of moderate to intense aerobic activity, cognitive exercise, nutrition, health monitoring, especially blood pressure. And if you look on the internet or contact the Alzheimer's Association, you can get more information on the Pointer study. But it's very exciting work that we can actually make a difference for ourselves. So I hope I shared with you that it's an exciting time for Alzheimer's research. We're understanding more, we're diagnosing more, we're treating more. In the clinic, you'll hear more about how we can offer anti-amyloid therapies. And there's lots of new drugs in the pipeline, and that's being worked on very actively at Sanders Brown, at other institutes, and very exciting with some of these new therapies that are out there. There's lots of risk and protective mechanisms for Alzheimer's disease. And if you want to lower your risk now, I say activity, activity, activity. And thank you for your attention.
Wow, that was great, Julie. Thank you. Okay, so next we're going to have one of our own wonderful faculty members, Dr. Greg Jicha, who I know a lot of you know, and he's a professor in neurology, also director of our clinical core for our Alzheimer's Center, faculty member in Sanders Brown, and he's going to talk about the latest and greatest breakthroughs in diagnosis and treatment for Alzheimer's disease. So please help me welcome Dr. Jicha.
I think I may have to come down in front as well because I didn't realize we don't have a way to see
Right, exactly. Yeah.
our slides.
Nobody, the speakers can't see their slides. That's why we're all down here.
So I thought that Dr. Schneider was just being super friendly by hanging out in front, but now I see her trick. Anyway. So welcome this morning, everyone. And yes, I know many of you and really respect you and appreciate everything that you do because the advances that we're going to talk about are because of you and your engagement that really help things move forward. They're not to my credit. They're not to the credit of anyone else but you. So really important. I wish that I could talk about everything that is exciting and breakthrough. I think Julie set me up for failure by kind of implying that I would. But I've selected a few things that I think, are really on the cutting edge. So we're really, really excited that for years, all of the brain donations, all of the cognitive testing, learning about lifestyle, learning about different proteins in the brain have brought us to the point where in the last few years, we have our first 2 medicines approved, disease-modifying therapies that can actually remove amyloid from the brain. We've never seen that before. So yes, there is a pot of gold at the end of that rainbow. It matters. It matters, the research that you do with us. So I'm going to start with that. And this is just one of those agents. But what we're starting to see currently is that the studies were done up to 18 months. That's the middle of this slide. But at Sanders Brown, we've been giving people these medicines after the studies, after the phase 2 and phase 3 studies for many, many years. And now we're starting to actually see that data come out. And so, let me see if I can fix that. Yeah. So what we're seeing is, yes, indeed, there's this slowing here shown at about 27% on a CDR sum of boxes at 18 months. And then at that point, everybody gets the real medicine, and that's more the norm than the exception these days. Most trials have what we call an open label extension, where you continue on, and even if you were getting the placebo before, you start to get the real medicine. And what we see is that the slowing then occurs in both groups. And this is compared to this blue line, which is ADNI, a control. They're not receiving any of the medicines. So we can see that the benefit, the longer you're on these medicines, the benefit seems to get greater and greater and greater. And this is really, really exciting because this has led now to FDA approval just in the last few months of maintenance therapy after 18 months, and we are treating people with both of these agents in our clinic, but after 18 months on this agent, you can receive ongoing treatment, presumably indefinitely until you reach a point where you're really at the stage of moderate Alzheimer's and they really stop working. So this is exciting. People right here in Lexington and Kentucky led to this that is helping tens of thousands, rapidly approaching hundreds of thousands, and possibly able to help millions in the nation. I just think that's incredible. And you know, we talk about slowing of the disease, and these are subgroup analyses, so you have to take them with a grain of salt. They're not definitive as of yet, but this is the exploration that is ongoing. And Dr. Schneider kind of alluded to this as well, that we think the earlier you give these medicines, the more impactful they can be. So this is really looking at over 18 months, what happens to people that were really, really, really mild, just the first whiff of a memory problem. And so while we see people with more advanced disease still decline, but slowing down, this is really amazing. After 18 months, 60% of people that were extremely mild actually improved. Getting rid of their amyloid was actually helpful. And on the other slide, what we see is the same sort of thing. This is based on the amount of tau, the amount of tangles in the brain. And so again, if those tangles are low in the brain and you get rid of your amyloid, you can actually experience improvement in up to 76% of people. So this is amazing. This needs to be verified. It needs to be looked at, but it's really driving. And so many of you are involved, the 2 ongoing studies, Trailblazer 3 with donanemab from the Lilly company, and the AHEAD study using lecanemab from Eisai are really exploring this now. And some of you in this room may actually be in those studies and receiving these medications. So that's really what research does. Also, the research participants, many of whom are in this room that participated in the studies, also were given the opportunity to go on and to receive ongoing therapy at home. give yourself an injection like a diabetic does. And those studies have been ongoing for the last several years. And just 2 months ago, the FDA approved the auto injector. So now you don't have to go to an infusion center and get an IV. Once a week at home, you can give yourself a shot and continue to reap those benefits. So again, when we think about research, oh, they're just going to learn things. It's not going to help me. It's not going to help others. That is completely wrong. It takes time. It takes science. It takes an army. But we're getting there, and we're starting to bend the curve. So really exciting. Julie touched on the U.S. pointer, so it's always amazing. Great minds think alike, I think. But I do think I'm going to give you my take on the pointer study, and then people can throw things at me or cheer me, whichever you want to do. But an incredibly important study funded by the Alzheimer's Association, looking at this combination. Let's not just fix one thing, but as Julie said, activity, activity, activity. We've got to fix as much as we can fix. That's what we need to do. And why do we need to do that? Well, you can see it up there. 35%, 1 out of every 3 older adults do not get enough physical activity. 81% are not eating right. I'm partially guilty there. 55% meet criteria for metabolic syndrome. We need to do something about this problem. So this is a synopsis from the scientific publication. I know it's a busy slide. I'm not asking you to understand all the tidbits on it, but it is kind of a summary. 2,000 people across the nation participated in this study. And indeed, the intervention was very rigid and structured. You go to the gym, you do your exercise, you hop on your computer memory thinking. And the other group, the placebo group, was they got all this information and said, you know, you really should exercise more. You really should keep your brain active. You really should keep your blood pressure and other things under control, and try to eat better. You know, maybe McDonald's decreasing its portion size is actually a good thing. Unlike what we hear on the media anyway. And indeed, this was just presented in July, August, and there was a positive effect in the study. I won't go into the intervention further, but this is what the primary outcome looks like. Really, really important. So structured on top and self-guided below it. And yeah, there was a statistical difference. The p-value is less than 0.05. But the truth of the matter is both arms improved. And Dr. Schneider alluded to that as well. So I think we really need to understand the benefit of this in context. So here's where my interpretation comes in. Erin, Dr. Abner can throw things at me as well. But this is what we call the benefit, the standard deviation change. And you can see how similar the structured versus self-guided are. But there is something called a learning effect, right? So I always say about the time that Dr. Van Eldik came here to the university in 2010, I got my children a Wii set. And there's a program, Wii Fitness. And it tells you, after you do these exercises on Wii, it tells you how old you are. So they were like, Dad, do it. Dad, do it. And so I'm like, oh, yeah, I'll do it. And I get up there, I finish my Wii Fitness exercise, and it pops up, your age is 85. And I was like, oh my God. So for the next 2 days, all I did was play Wii Fitness till I got it down to 25, right? Now, I didn't really take 60 years off my life. What I did was I learned the game. So there's something called a learning effect. And a learning effect is a practice effect. So if we look at this, and I took this data actually from a study done at Rush at Julie's shop, if we don't look and subtract the learning effect from the effect of the intervention, these are the curves that we get. And then we have to think, what's the expected change in somebody with moderate risk for future Alzheimer's? And that's been well worked out from research as well. And it's this orange group. And if we pull all of that data together, we can start to look at, well, if you spend a year doing everything you can, doesn't matter if you're in a structured program or you're doing it by yourself, as long as you're doing it, you can buy yourself an additional 1/3 to 1/2 of a year. That is incredible in age-related cognitive decline. Now, the difference between the two groups is only about 8 weeks. So if you want to do something very regimented and structured, you might get a better benefit from it, but do something. It doesn't have to be an expensive gym membership. It does not have to be an online computer game. It can be anything. Just do it. So let's all get started. After we're done digesting that breakfast this morning, there was fruit that was healthy with our brain health activity program. So I do want to turn to something and really just announce. Sometimes we hear folks, well, we can't get into any research programs at Sanders Brown. It's full right now. We're on a waiting list. And that's a real problem for us. And we know we need lots of people to answer these questions, right? We couldn't answer the pointer questions with 20 people. We needed 2,000. Right? We need thousands and thousands of people to understand these problems. So this is a new initiative for us. It's called Be Bright, standing for Behavioral Biomedical Research in General Health and Thinking. And I really love my logo for it. Easy peasy, lemon squeezy. Anyway, what is Be Bright and how does it work? Well, this is something, we have a lot of folks, Pikeville to Paducah, we say, that are 4.5, 5 hours away by car. And to come and participate in research, it's a 10-hour round trip. We've learned over time that we can indeed test memory and thinking and collect data remotely using internet, Zoom, many people that are online for this program today, and that information is very useful. So 30 minutes to an hour a year, you can get engaged, and there's really no cap on this. We're looking for folks primarily in Kentucky, but we are expanding to surrounding states. So who might be ideal for Be Bright? This is really, really important. Well, sometimes folks don't want to. Our program as well really wants autopsy from everybody, and not everybody can or is willing to give their brain for donation at the end of life. And some people don't want to do MRIs and PET scans or get a spinal tap in clinic with me. And this is a way to engage and help. Without that, we have many that come in, mom or dad passed away from a dementia, and they want to engage, and we're like, well, I'm sorry, you're not 65 yet, and we really study 65 and older. We need to study midlife risk factors. This is giving us the opportunity to start looking at those 50 and older, people that can't travel to Lexington, not just those that live in Paducah, but what if it's really hard for you to get around? And we try to do home visits as much as we possibly can for folks that are close, but this gives us a new opportunity for that. So really, it's our motto, something for everyone. It takes an army. So what are we going to do with this? Well, we will learn a little bit about everybody, and that's going to be able to personalize, So in the future, it's not just come to a Markesbery Symposium for everybody. Yes, you'll be able to do that too. But also, we will be guiding and sending you materials about you. Hey, wait a minute, you're not exercising enough. Let's ramp it up a little bit, guys. Let's put some structure to that. We'll be able to tell you, oh, we have these other studies, and instead of trying to pick out a brochure from a table, we will actually say, you look ideal to help with this. Would you like to help us? So really personalizing that, and again, that annual feedback to help you guide your brain health activities. So everybody says, well, what questions could you answer scientifically with a cohort like that? Well, how about midlife influences? Hypertension takes its toll in midlife. So we need to understand these other midlife influences greater. We really hope that this opens up opportunities for a broader population. We can study more people that live in rural Appalachia. We can potentially engage people that are hesitant to get involved in more extensive research. And of course, we do a lot of ancillary studies with our group. So I'll just talk about 3 that we're doing currently. These are really important topics that I want to know the answer to, and I bet some of you do too. So what about trauma, post-traumatic stress disorder? We've had a lot of weather disasters in Kentucky. We've had entire communities devastated by floods, devastated by tornadoes, economic deprivation, racial and ethnic discrimination. How are these impacting and changing our risk for dementia and or lowering our resilience, as Dr. Schneider talked about? We don't really know, but I think the answer is really, really important. And we need to find it out. And Be Bright's going to help us do that. How about COVID, long COVID? We've heard about that. We certainly know it exists. How prevalent is that? How is that changing future risk for memory and thinking decline? What about vaccines? Are the vaccines creating similar sorts of problems that some have questioned? Now, I have my clear beliefs on that, and I won't voice them here in front of the entire group, but I will say I was flu and COVID vaccinated last week. In general, we need to understand this. Not everybody responds the same way to an illness or to a vaccine, and we need thousands of people to answer these questions. Be Bright can help us do that. We're also surveying folks right now on intermittent fasting diet. Maybe it's not what you eat as much as when you eat it. So we have a graduate student working on this currently, this project. He does great work, and we're trying to gather information on when people eat from thousands so that we can answer that question. And many, many, many more. We do this multiple times per year, answering critical scientific questions. We know it's going to take tens of thousands of compounds, of new medicines to eventually cure Alzheimer's disease and related disorders. We know that it's going to take tens of thousands of research participants, if not hundreds of thousands, and lots more funding and money. So I think that that's important. And one day, dripping out of the bottom of that funnel, we will see that cure. We will see that cure. So I hope you all get involved. In your flyers is an easy peasy, lemon squeezy way for you to get involved if you're not already involved with us. So with that, I'll stop there. Thank you.
Thank you. Thank you, Dr. Jicha. That was wonderful. And so now we're going to have a real treat. We're going to have a very brief presentation by a person who is on our participant advisory board, so works closely with us. This is Lee Edgerton, so please welcome him.
You can see I don't have any slides, so that's not my excuse for standing down here. But I've got a few people in the audience who are yoga buddies with me, and I don't want them reporting that I tripped going up or down the stairs. It's a real honor to provide a perspective on the benefits of being a participant in Sanders Brown programs. This is supposed to represent all of the participants, but I'm one participant, so I'll start by sharing briefly who I am. I grew up in a small rural community of Kuna, Idaho, and I went to the University of Idaho with dreams of studying genetics and creating the finest dairy herd in the country. 5 years and a dose of reality later, I enrolled in a doctoral program at Purdue University to study reproduction in livestock. One of my graduate student buddies elected to study under a young professor whose work focused on the brain. This was 1965, and I thought, how sad. In my mind, the brain was such a black box that he would never be able to come up with any useful information. Today, of course, there's still a lot we don't know about the brain, but thanks to people whose foresight was better than mine, we've learned a lot. And thanks specifically to researchers such as those in the Sanders Brown Center, we're learning a lot about the aging brain, such as the one that I have. I started in the Sanders Brown program at the ripe young age of 60. I don't think we're taking them that young anymore. Maybe I was precocious. But involvement with Sanders Brown has piqued my interest in the brain, and so I've read a number of books about the brain and brain function. And the professional staff at Sanders Brown helped me to clarify and verify or reject what I think I know about the brain. And the frequent reports that they give on these studies is a tremendous information source. And so the number one benefit that I would see as being a participant is that I have a better understanding of the process of aging and of what's happening to my brain than I would have if I were not in those studies. Now, these reports also give me a sense of purpose, of value. Being part of the longitudinal study means that I've been afforded opportunities to participate in a number of other studies. And you may think that this represents a particular pathology of this particular brain, but I remember very fondly one study in which multiple blood samples were drawn from me throughout a rather long day. And Dr. Jicha even removed some spinal fluid for good measure. And so when I hear these reports on what we're learning about Alzheimer's, it gives me a real sense of value. I think one of the things that I learned is that we participants don't have skin in the game like Dr. Jicha, Dr. Van Eldik, and others at Sanders Brown, but by golly, we've got blood, spinal fluid, and MRI scans in the game. And if Dr. Nelson is successful in harvesting our brain within a reasonable period of time at our death, then our brains are going to be as committed to finding answers to brain issues as the brains of any of those staff members at Sanders Brown. So it gives us a real sense of purpose. In between the procedures on that day, I enjoyed visiting with one of my fellow participants, and that reflects a third benefit, and that is that we remain socially engaged. Not only have I enjoyed visiting with fellow participants during the research studies, but I've been fortunate to be on the participant advisory panel. And that means that we learn a great deal about what's going on at Sanders Brown. It enhances our sense of value as they seek feedback from we participants about the current programs and future programs at Sanders Brown. And we learn a great deal from the personal experiences of the various members on the board. Now, relative to social engagement, I also want to thank staff members like Kelly Parsons, who promote participation in OLLI, the Osher Lifelong Learning Institute at UK. OLLI provides programs related to intellectual activity, physical activity, and social activity. Activity, activity, activity. Have we heard that this morning? So I appreciate that Sanders Brown is a real cheerleader for the OLLI program at UK. A fourth benefit that I see is an additional set of eyes on my personal health and well-being. As an example of that, I was diagnosed with MDS, myelodysplastic syndrome. This happened because I had volunteered for a study at Sanders Brown. And following the initial evaluation, Dr. Jicha said, "You're not a good candidate for this study." How could that be? Well, I was low on white blood cells, and one of the drugs that I might have been assigned to in that study had a side effect of lowering white blood cells. So he didn't want to put me in double jeopardy. But beyond that, he said, "May I contact your primary physician and recommend a complete blood evaluation?" And that led to the diagnosis of MDS by the Markey Cancer Center. Now, that might have been identified later on in a routine health evaluation, but it was identified first because I was part of the Sanders Brown program. And I think we all know that early diagnosis is a key factor in treatment of many diseases. So, health benefits for being involved with it. I think that also reflects their general interest in us, and that is my final benefit. That is that there is a general concern about our well-being. I see that routinely in their care for us, in the fact that they put us first, and anyone who's considering participating, I think, can be interested in that. So I've quite honestly forgotten, I'm just saying that for those of us who are struggling with memory, I've forgotten one of the points I was going to make, but I'm going to finish with an anecdote that I think illustrates this. My wife, see, it works. The brain's coming back. What I was going to say was that my wife, who's also a participant in the study, had a stroke in 2018. And so when we have our annual checkups, not only am I evaluated, not only is she evaluated, but we're evaluated as a couple. And there are frequent conversations about caretaking and responsibility for one another. And Melinda and I are much better prepared to face the challenges we have today and the challenges we're going to face because of those sorts of discussions within Sanders Brown. Now, that last anecdote I want to tell. Melinda and I each have over a couple of decades experience with the longitudinal study. That's a lot of investment by Sanders Brown. We recently purchased a home in Topeka, Kansas. That move is going to put us close to our daughter and her family. But because Sanders Brown has invested so much in us, I thought when I informed April Stauffer, the program coordinator, that we would be moving to Kansas, that at the very least I would hear, "Oh no, you can't leave us." But April said, "That is terrific. You are going to have so many new and exciting experiences." Now, April says she didn't say this, but I inferred that those new and exciting experiences are going to add years to my life. So, in conclusion, I want to say thank you to all of the staff at Sanders Brown for making us more informed about the process of aging and about issues with dementia, for giving us purpose in our senior years, for providing social connections, for giving us health care and advice, but most of all, for providing encouragement and TLC in abundance for those of us who are privileged to be participants in the work of the Sanders Brown Center on Aging. Thank you.
Thank you. That was terrific. So before we go on the coffee break, it's because I always forget to do this at the end, I just want to make a big thank you to everybody who has come here today. I don't know that we've ever had such a crowd and we also have about 100 or more, Ryan can tell me how many, online in addition to all you guys. So that's terrific. The other thing I want to express my true thanks to all the Sanders Brown folks who made this possible. I'm not going to name everybody, but you just heard April. She's been doing a lot. Bev Bassler, Charlotte Wood, lots of people. And we couldn't have done this without them. So thank you. So we're going to take a little coffee break, but please come back here by about 10:30. We're going to start right at 10:35. And if you want to leave your card, the little card with any questions, please do that. Okay, everybody, let's get started again. A couple of announcements before we start. If you have any last minute burning questions, Dr. Estes there will take your cards. Okay, Dan Lee in the back. Annika, they're waving. They're going to take any more of your questions if you have them. The other thing is I wanted to explain about the parking because we have had a few questions. So when the event is over and you fill out this blue evaluation form, you're going to give it to whoever is standing at the doors. They're going to give you a little card that has a QR code on it, a little piece of paper with a QR code. When you get back to the parking lot, there's either going to be an attendant at the booth. If there's no attendant, there'll be a scanner machine. You just scan that little QR code, it'll open up and let you out so you don't have to pay anything. Okay? All right. So I'm very pleased to introduce our next speaker, Dr. Erin Abner. She is from Sanders Brown as well. She is also the chair of the Department of Epidemiology and Environmental Health. And she's been a wonderful participant in our running of our Alzheimer's Center. She is the director of the Data Management Core. She's just an all-around wonderful researcher. And she's going to talk today about the case for public trust in Alzheimer's research.
Thank you for the introduction, Linda, and thank you to the organizing committee for inviting me here to talk to you today. I'm really honored to be in front of you and have the opportunity to talk to a lay audience about sort of the behind the scenes things in Alzheimer's research and to explain a little bit about the news stories that you may have seen earlier this year and over the last few years. So the first thing I want to do is give you my disclosures. I don't have any financial conflicts of interest that are going to drive anything that I'm telling you, nothing to do with any pharma companies or anything like that, just grants from the NIH. I'm a paid editor for a journal, and I am a member of external advisory boards that give me an honorarium. So as I mentioned, right, over the last few years, Alzheimer's research has come under increased scrutiny, not just in the media, but from the public and the federal government as well. And why is that? Well, what has that looked like? So here's a headline from 2019, for example, talking about some sort of nefarious group of Alzheimer's researchers, which I'm not sure that's a real thing. And here, another story from 2022 talking about some possible fraud or actual fraud in Alzheimer's published research. More. And this one, frankly, really hurt on a personal level. Dr. Maslio is someone that we all really respected and looked up to. More. Right, and so fair enough, right? There's clearly something happening here that's important for us to engage with and think about and try to understand. So we might hear people say things like, I believe in science, or science is real, right? And okay, but I'm not here to tell you to do that. I don't want you to feel like just because somebody says something is science or it's research, that it's automatically trustworthy and valid, right? So science is just a method. It's a way of answering questions about the world. It isn't true, it isn't false, it's a method. But the biggest problem with science is that its practitioners are human beings, right? And so you all know people, right? You've all met people. And so we know that like any human enterprise, then science is vulnerable to both error and fraud. That's absolutely the truth. So given that, these terrible headlines and the fact that it's true that some of these things have happened. So why should the public have trust in Alzheimer's research? One of the things I want to point out here is that there were lots of headlines, but they really relate to just a few individuals. Now, that doesn't mean that there aren't cases of fraud and error out there that we don't know about. And so I'm not saying it's literally just these people that have ever done anything wrong. But all of this coverage was generated by just a few people. And even if it is just these few people, it doesn't mean that what they did couldn't have been very harmful, right? But it matters whether they did cause a lot of harm or whether they didn't, in fact, cause a lot of harm. So the main controversy here is about something called the amyloid cascade hypothesis. And you may have heard about this before. And Dr. Schneider today mentioned amyloid and tau as being the pathologic hallmarks of Alzheimer's disease. They are what the disease is. The amyloid cascade hypothesis has been around since 1992. And it is the idea that the first pathological changes that happen in the brain are the abnormal accumulation of these A beta or amyloid beta deposits. And so this figure shows us this yellow line. So it's a conceptual figure. It's not based on like actual data, but it says we think that, you know, long before we have symptoms or anything else happens that goes wrong in the brain, we start to get this buildup of amyloid. This C here stands for cognition, and we can see time-wise, cognition is way out, right, from that initial accumulation of amyloid. And then there's some other pathological things that are happening in the middle, including the accumulation of tau in different regions of the brain. And particularly when we get here to this red line, where tau is in the neocortex, or this area of the brain, we almost always see cognitive impairment at some level, and quite often very severe cognitive impairment. But not everybody agrees that the disease happens this way. And of the cases that were presented in these headlines, really only one of them involves the amyloid hypothesis in any significant way. And to be fair, it was an influential paper. You might see, if you ever see it discussed in the media, they'll say it was cited over 2,000 times. That's true, but that doesn't mean that everyone who cited it said, here is this great true thing that I am now citing, and taking is true. Whoa, taking is true. Hello. Okay. Taking is true. But it hasn't been that influential in the way that it was presented. That's fine, we'll be in the dark. So I'm arguing that in the media, the line of argument has been that this is a field-defining line of research. You might have noticed the headlines say things like, 16 years of research, is it all a waste, right? Or is everything we know about Alzheimer's wrong? And if this was true, it would absolutely be an immense tragedy and a disaster. But I'm arguing that it's not true, that this paper was that influential and that it really underpins what we think about the disease process in Alzheimer's disease. So the amyloid hypothesis, as I mentioned, has been around since 1992. The paper in question was from 2006, so obviously it's not the foundation of the amyloid cascade hypothesis. The specific paper in question focused on forms of amyloid called oligomers, which are smaller than amyloid protein itself. And the paper didn't establish the idea of oligomers either. Those have also been known and studied since the 1990s. The issue at this particular paper is an oligomer that they called A beta star 56. And in particular, they said that they had discovered that A beta star 56 was the component of Alzheimer pathology that causes cognitive impairment and dementia. And so the idea then is that this discovery led to everybody focusing on A beta star 56 and trying to develop treatments around that particular pathology. But it has long been known in the field that the results were not replicable outside this particular group of people. And scientists are really skeptical. Just for example, to bother Julie, but yesterday she was talking about a paper that we had published that was led by Dr. Nelson. And when she saw the results, she was like, I don't know about that. Which is fair. We all do that, and we should do that, right? We are skeptical of these new findings that say, oh, hey, here's this big deal thing that nobody knew about. And we're like, but are you sure? Are you sure about that? And we'll go and do our own research. Like Dr. Schneider did her own study, and then she was like, okay, I guess it checks out. That is true, that's fine. But we are skeptical of ourselves and each other. And so I think another important question is, of this particular work, was it really that influential? Yes, lots and lots of citations, but an interesting quote in one of these articles about Matthew Schrage, who's a very competent neuroscientist, neurologist, who did a lot of the investigation work that uncovered these problems in these papers. I was really struck by this sentence that says, these papers about this A beta star 56, the investigator had never heard of him. And to be fair, I'd never heard of him either. And I've heard of a lot of people. A lot. So, okay. So I hope that you will at least consider the possibility that that particular line of research was influential in that it led people to be more interested in A beta oligomers, and people went and did other things with that line of research. They did not spend 16 years trying to find A beta star 56 and what have you. But what about the amyloid hypothesis more generally? I mentioned this is controversial, and there was that headline about the cabal of researchers preventing any other type of research being done. Could that be true? Was there a malicious group of Alzheimer's researchers preventing other people and other lines of research from moving forward? It's funny, but these stories never mention that until about 10 years ago, there was very little funding at all for Alzheimer's research at the federal level. It wasn't until, and we can see these in millions of dollars, just to point out, this is 2014, 2015. We've got about 500, 600 million annually total for all Alzheimer's studies versus where we are in 2025, where we're over 3 billion. Okay, so if you only have $500 million, what are you going to do? So in 2010, you may know that the National Alzheimer's Plan Act was passed, but it didn't have any funding, right? There was no law attached to it that said Congress had to appropriate any particular amount of money to make sure that the goals in the National Alzheimer's Plan Act happened. And so the Alzheimer's Association continued to lobby Congress, and eventually they were able to secure legislation that funded NAPA goals. And that's why we see that dramatic increase in Alzheimer's funding. But if you only have, again, that limited amount of money, what's the most reasonable thing to do with it? Is it to invest it in an area that has a lot of really strong evidence and support? Or is it to really broadly disperse the money for every hypothesis that could possibly be chased down? I don't know that there's necessarily a right answer, but I hope you agree that at least it's not unreasonable to invest in the hypothesis that appears to have the strongest base of evidence. And as we've seen from Dr. Jicha's talk, this has paid off, right? We now have anti-amyloid drugs that do something that's never been done before, which is to slow the course of Alzheimer's disease. And that's a big deal. That's not a small thing at all. And now that there is more money, all of these things are funded. All of these lines of research are active, right? Inflammation, infection, tau, other pathologies, exposome, right? All kinds of things are happening now because there's money to go around, and before there just wasn't. So what safeguards are in place, generally speaking, to protect the integrity of research that's funded and published? Because that's really important. So I want to tell you that there's many levels of scrutiny. We don't just get to do whatever we want. Surprise. So most of us work, most of the people you've heard from, work at universities, and there are teams of professional staff who are specifically in charge of making sure that the research that's conducted at that university or that institution is done with integrity and according to the law. At the University of Kentucky, 3 of these are the Institutional Review Board, the Office of Sponsored Research, and the Office of the Vice President of Research. I hope you will agree that the best way to avoid negative public attention if you're an institution is not to have anything happen that brings negative attention to you, right? To prevent that bad behavior. And so at the University of Kentucky, this involves training, continuing education, and the responsible conduct of research, and importantly, strong penalties for people who are found to have committed research misconduct. For example, just last month, or now 2 months? I don't know, it's November 1st, bear with me. In September, so just in September, right, a tenured faculty member was fired from the University of Kentucky after an investigation conclusively showed that he had fabricated lab results for projects he was working on. It's not just a slap on the wrist like some people might have you believe. The universities don't want to keep bad researchers on staff. It doesn't benefit them at all. So that's about at the institutional level. What about when we apply for grant funding? What's happening there? So when we submit grants for funding, those are reviewed by other scientists, not by government officials. And conflicts of interest there are really carefully scrutinized. You cannot review the grants of your institutional colleagues, even if you've never heard of them. So I would never be able to review the grant of anybody from the University of Kentucky. You can't do your friends. I wouldn't do any grants that Dr. Schneider submitted, for example. That would be a conflict of interest. You can't do your mentors' studies and grants. You can't do your mentees, people you work with or have worked with outside your institution, and that's just a fraction of it. There's other things too that exclude you from reviewing a grant. What about papers? So how do they get into these journals? Again, multiple layers. Now we have technology that wasn't available before, and just about every journal in our field uses software to examine all of the figures that are submitted in papers to make sure that they have not been edited or manipulated to show something that isn't real. So we have that. And then we have manuscript reviewers, again, who are other scientists who are subject to all of these conflict of interest rules. But obviously this isn't perfect. Things are going to get through. we don't review grants and papers with the assumption that someone is trying to defraud us and trick us, right? So we're reading in good faith, assuming that the researcher is acting in good faith as well. And so sometimes you miss things. And people who are determined to cheat, as you probably know, will ultimately find a way to do that. But I'm here to tell you that it is really difficult to cheat in science and get away with it in the long term. So even if it's a short-term success, eventually you're going to be found out, you're going to be publicly humiliated, and your career will be destroyed. Huge risk to take, in my opinion. So most people don't do that. And science requires the replication of results. Dr. Jicha mentioned some early encouraging results from the extension studies on Leqembi, for example. But he stressed several times, we need more research. We need to know if this is a real thing or if it just sort of looks like this is what's happening. And so I do want to encourage you to always be cautious the first time you hear any new finding. Hold some skepticism, right? Wait for additional evidence to come in. And finally, most of us, almost every person I know in the field, is in the field because of personal reasons. Their parents have had dementia. Someone in the family has had dementia. So we're really here trying to help solve a problem that's also affecting us. And so for me, I am related by blood to 3 of the 4 people in this, obviously my granny and papa, my granny's sister, Aunt Tittle, and her husband, Uncle Mac. Granny, Papa, and Aunt Tittle all died of Alzheimer's disease. It's in my family. It's a big time in my family. And so this is personal for me. I'm not here messing around, trying to cheat and get by and publish papers, right? I care about this. And I think every scientist that I know personally, that's true for them too. And so with that, I'll thank you for your attention and we'll welcome the next speaker.
Thank you, Erin. That was great. One quick thing, I was made aware that someone has lost an earring. It's a little gold screw-on. So if you happen to find one on the floor, no, I don't mean you lost it. I mean, it's somewhere. It's either outside or inside, but if you do happen to find it, just feel free to bring it up to me or to any of the people out on the tables. Okay, so we left the best for last. Our next keynote speaker is Dr. Andy Saykin. He is the director of the Indiana University Alzheimer's Disease Center. He's also a professor in several different departments, a very well-known neuroimager in the field. And he's going to talk to us today about the road to personalized medicine for Alzheimer's disease and related dementias.
Thank you very much, Linda. It's just fantastic to be here at one of our partner centers in the network, and a terrific center just a few hours south of Indianapolis where we're based. I'm also going to look over this way so I can see the slides, but apologies to those on the other side. So I have the pleasure of following 4 fantastic talks covering some of the same things that I'm going to mention. I'll just skip over those. Maybe there'll be a reminder. But just really, really outstanding. And I appreciate all of what we heard. These are my disclosures and our grateful acknowledgement of grants and topics. Basically, what I'm going to do is kind of show where I think things can go looking forward. But looking back a little bit first, all right, plaques and tangles, amyloid and tau. Yes, the field's been preoccupied with those, but for good reason, as you heard, and it makes sense to, with limited resources, to start there. I thought Dr. Abner made a great point about that. You heard about risk factors from Dr. Schneider and Dr. Jicha. I won't go through them again. They're just listed up here. Many risk factors are known from the epidemiology and from various clinical follow-on studies. This is really helpful. And of course, many of these relate to modifiable factors. Also, a lot's been known about what's protective and can support resilience and reserve. You heard a lot about these earlier, and I won't repeat them, just show you some pictures. But I'll also mention depression, anxiety, and other kinds of neuropsychiatric symptoms, which also can be a source of cognitive challenges and sometimes can complicate our differential diagnosis of what may be Alzheimer's disease or another neurodegenerative disorder, that there's some misfolded proteins, or maybe there's a primary psychiatric disorder. And sometimes these co-occur as well. So we're learning more and more about the relationship also of things like amyloid and tau and neuropsychiatric symptoms and so on. But that's still a very emergent area. So my theme is, how do we go from amyloid and tau-centric focus to a precision medicine? And maybe if your problem is only amyloid and maybe tau, then that's precise enough. We have some therapies that you've heard about that are very exciting. Maybe targeting those pathologies, the answer. But things are much more complicated, as you heard from Dr. Schneider earlier, when you look at the neuropathology. There are multiple factors. I'm going to touch on some of the other ones. What are the other things that now that there is more funding have been studied, can be studied, and how do we put those pieces together? So what's this precision medicine or personalized therapy? You might hear of tailored therapeutics, a bunch of related terms for this. All of it means really focusing on the individual, getting a very individualized profile of what's going on, strengths, weaknesses, biological data, clinical, cognitive data, everything we can learn, risk factors, protective factors, and tailoring the strategy for the individual. And frankly, as you probably know, this is aspirational. Right now, we have relatively limited diagnostic tools and relatively limited therapeutic approaches, but those are terrific that we've gotten that far, and they point in the direction of where all this can go in the future. And the goal is often stated as having, the right treatment for the right patient at the right time. And that might be the right dose and sequencing and some other things as well. Okay, so how do we get there? One of the most important concepts that you also heard a little bit about earlier is the idea of biomarkers. And the FDA and others actually group biomarkers into some different categories. So just briefly, there are biomarkers that you're born with. So your DNA profile, your genome, your 3 billion base pairs, that big alphabet of letters that's 3 billion long, actually 6 billion if you count what you get from your mother and from your father. So, that's locked in, and that is a susceptibility or risk marker. There's some major genes that we know about, ApoE, especially the E4 allele that you've heard about, I think, is the big one. But there are also many other ones that contribute in a smaller way, and we're learning about that. But then, you're born with your DNA profile, but say at age 72, Mr. Jones comes into the doctor's office and feels like his memory is slipping. At that point, it's not so, well, we could see if there's an ApoE genotype, which would be a risk, but it really doesn't tell you anything about current state. What will tell you something about current state is a diagnostic or dynamic biomarker that can be measured. So, I used to say it'd be the holy grail to be like cholesterol, where we'd have a blood test, for Alzheimer's disease. Well, the holy grail has been found. There's now 2 FDA-approved blood tests for Alzheimer's disease, as you heard earlier, and more coming. There are also cerebrospinal fluid tests and PET scans, and we have a lot of tools. There's a lot of work on digital biomarkers, digital speech analytics, all kinds of different things now, actigraphy measures, and a whole range of ways of collecting data, all of which can be informative. Some may be more important than others, but it's a tremendous wealth of information. Other biomarkers that are highly desirable and are being investigated are prognostic biomarkers. Can we tell if you do have amyloid or some other misfolded protein, are you likely to be stable for a long time and it's going to be relatively benign? Or are you going to crash and burn and have a lot of problems, go downhill fast? If we knew that, that could also help inform risk-benefit analysis and what type of treatment strategies and personal planning and all kinds of other things that would be really useful. And then eventually we want to have biomarkers that can profile and predict who's going to respond to what treatment, because it's not going to be a one-size-fits-all for many, many reasons. So the goal is ultimately to have this personalized. In cancer, they've been pretty far along in this, doing all kinds of sophisticated testing to understand tumors, what staging and so on. And we can learn something from clinical trials in oncology as well. But anyway, they're a little ahead, but neurodegenerative disease and aging research is catching up rapidly. So some of the important imaging biomarkers are shown here. On the left, you see the A, T, and the N, that's amyloid, tau, and neurodegeneration. We have a new alphabet now for biomarkers, ATN, and we're adding to that alphabet as well. But that's amyloid, tau, neurodegeneration. So the red areas in that the sagittal scan through the middle of the brain with the A there, those are showing areas with deposition of amyloid in a patient from IU that had mild cognitive impairment. The one on the right, that coronal slice from front to back, that is a tau PET scan that's showing tau deep in the temporal lobes on the side of the brain. On the bottom is the brain actually isn't colored like that, but those are showing some different brain regions that can be measured. But that gives a quantitative measurement of atrophy. I used to have students in my lab back a number of years ago. A lot of this was back at Dartmouth when I used to live in New Hampshire. So we'd have people sitting on big workstations tracing brain regions, and then for replication, which is so important, as Dr. Abner mentioned, we would have people trace it twice themselves, then another person would trace it twice. It took forever. It was really inefficient. Now we have high throughput computational neuroanatomy. We can take an MR scan, put it into the computer. Within about an hour, we can get quantitative data on cortical thickness and all those regions, the volume of the hippocampus, this shrimp-like structure on each side of the brain deep in the temporal lobes that's critical for supporting memory. So we have these great tools. And then on the, you heard a lot earlier about vascular pathology. So that's an MRI scan called a FLAIR that is very sensitive to vascular pathology. Let me see, I do have a pointer here. At least those of you on this side, you can see these bright areas. So those are hyperintensities, and they typically reflect vascular changes in the brain and are a way to quantitate and measure that. So we do have a lot of biomarkers. We also have fluids that can measure amyloid and tau, both in cerebrospinal fluid, as Dr. Jicha was talking about earlier, and then also now blood tests. So these have really revolutionized our research as a field. This famous paper from the New England Journal is about the rare group of individuals that have autosomal dominant Alzheimer's disease. It's only about 1%. But I want to show this because all those colorful spaghetti-like lines, those are biomarker curves. And in this case, because people have a mutation that causes the disease, very rare, only one, maximum maybe 2%. But in this case, you can estimate based on family history when the person will develop dementia. And that lets you collect longitudinal data from family studies that are affected with these mutations and model out, where do the biomarkers change. And this study demonstrated that biomarkers start to change about 20 years. This minus 20 here, this red arrow, is where you can see the curves start to separate. Some go up, some go down, depending what they are, but changes can be detected that early. And later, it's been shown that in people with sporadic Alzheimer's disease not caused by these mutations, we see the same thing. There's about a 20-year window from the earliest detectable changes to symptoms and then dementia. So think of the strategic opportunity we have for 20 years to intervene. So a lot of what you've been hearing about earlier this morning can be done in those 20 years if we do the early detection. Some people say like, well, why would I want to know? Why should we be, looking at these risk factors and biomarkers? There are things that can be done, and we can do the research to do more things if we do that early detection. So what about the clinical part of this? This is from a staging framework. In all the talk about biomarkers, we still have to remember the individual. And one of the things I've been interested in for years before these biomarkers, in fact, it used to be the only thing we could do if we wanted to do early detection back when I was sitting in the hills of New Hampshire at Dartmouth doing these studies is we'd have to ask people, how's your memory doing, that Mr. Jones who comes in at 72, he says, I'm perfectly fine, I'm great, but maybe somebody else comes in and says, my memory is not what it used to be. I feel like it's slipping. And at first I actually found that I was trying to recruit people that had real memory problems. I got all these people coming in that some people told me, oh, those are the worried well, that just seem to have memory concerns. Well, long story short, we decided to change our design and start assessing people that had these subjective concerns. And it turns out that we were actually seeing things on MRI scans. This study, I think we published this back in 2006, the first one in the upper left. We were basically seeing things that looked like what we saw in the brains of people with mild cognitive impairment or very, very early stage Alzheimer's disease in people with a lot of concerns. So it's not just the worried well. It might be, but it might not be. And we didn't have amyloid PET and tau and all these other things. Now we can combine people's subjective perception, also, of course, family members and other knowledgeable informants who know person well. We can integrate that information, and we've actually found that we can quantitate some of this and with some scales to measure subjective concerns for memory and other cognitive functions, and look at the relationship of the individual, of their family, partner, informant, and others, and clinicians. And we've, in fact, Dr. Jicha and I were co-chairs on a committee for the Alzheimer's System Network. We've actually built several of these questions now for the first time into the assessment package that's done in all the Alzheimer's centers around the country. It's just a matter of asking about things. So again, this is the Dr. Daig, who's at our center now, but when Lilly developed that first blood test for Alzheimer's disease that measures phosphorylated tau in blood. You saw this curve earlier showing the first FDA-approved amyloid therapeutic. That's great. So therapy now, on average, can reduce the rate of decline by about 30%. Okay, that's fantastic. It's a huge, huge development after hundreds of failed clinical trials. It's a really big deal. Now, what do we do to not only bend the curve, but flatten it out? How do we get the rest of the way there? So that's the rest of my remarks will be looking that way. So, all right, now, amyloid and tau, very, very important, but there's a whole realm of biology. We call it systems biology. It's the big picture of everything happening in the body. And I don't just mean in the brain. The brain is obviously very important. It's the organ system of greatest interest for what we're doing, of course. But it turns out, well, there's this gut, liver, brain axis. There's all kinds of other organ systems in the body that, are mostly other specialties because, medicine is by and large chopped up into all kinds of specialties and subspecialties. But it turns out you also have to put all the pieces back together and understand how they work in conjunction. Because, I like to say as a neuropsychologist by training, I never in a million years would have thought I'd be studying stool samples to try to understand something about the brain. They're probably not to my face, but there may be people who think I'm full of it, but we'll see. It turns out that a lot of other scientists are working on this too. And we think, once you start to look at things that didn't get any attention previously, you start finding things. And yes, Erin, they have to be replicated. Otherwise, we don't believe any of them, right? But at least once, and ideally replicated multiple times in multiple independent centers and cohorts. But then we've got something solid as scientists and clinicians as a platform to build on. So we need to, turn over every stone, because it could turn out that things that are happening in the liver, and I saw some of the students here I saw posters yesterday of people studying ApoE and Alzheimer's related protein, but in liver as opposed to the version in brain. So, these are just really important. We've got to look at the kidneys, we've got to look at all the systems. Okay, now, amyloid and tau are two slices of this big pie, which is a massive literature search that we did, looking at about the last 20 years of research. A lot of it since the funding increased, but what you can see is that, let's see, this is the, going to go back here. This is the amyloid and the tau slice. Okay, maybe that's a quarter of the pie, but there's another 3/4, right? So someone said earlier, oh, nobody mentioned the synapse, right? Which is really important in neurodegenerative disease and for many other things. That's in here. Neurodegenerative changes in the synaptic connectivity, oxidative stress, and the immune function and mitochondrial energy dynamics. I won't read them all to you, but there are many, many pathways. There's probably about 25 that have been intensively studied, and they are being pursued now. Okay, and why is, as part of precision medicine, it's often associated with genetics, but it goes even beyond genetics, really. But why are genes important? So the genome was sequenced, more than 2 decades ago, and now there was a big expectation. Why aren't we curing all these diseases, cancer, heart disease, and neurodegenerative diseases? Well, it takes time, and we have to understand the function of these genes. But there is evidence that when genetics informs drug development, there's a much higher rate of success. That's the key statistic, and that's been replicated in a couple of different studies. So that's one important reason. Okay, but in addition to just the DNA profile that I mentioned, those 3 billion letters of the alphabet, there's also functional genomics and what we now call multi-omics. That's sort of the latest thing, I guess, if you will. And it's in part because technology has taken off in a way that's unbelievable, where actually when, just a little over 20 years ago, we would have to look at one letter of the alphabet in the genome at a time, and we'd have to pick it and say, that's my hypothesis. I want to look at, some variant in the ApoE gene or some other gene. Now we can sequence the entire human genome for under $1,000. And we can now also look at what are the functions of those genes? How are the genes expressed? So just to kind of look at the omics world here, if you will. So we go from the genome, next up is the transcriptome. That's the expression of all those genes. And they're making protein products. So the next thing is the proteome. That's the ensemble of all the different proteins that are formed. That's the essential biology pathway here, is from DNA to then form RNA to then code for proteins and form these proteins that then go into various metabolic processes. So the thing is, we have tools now for, in the, not in the millions and millions, but in the hundreds of dollars per person, we can actually get the thousands of proteins. We're working with an array now that gives us 11,000 proteins that we can get from a tiny drop of blood. It's really quite remarkable. And then there are many other features. I won't go through them all. I mentioned the gut microbiome. There's metabolomics and lipids like cholesterol, but you hear about triglycerides. That's like one number, right, in your blood panel. But there's like 100 of these things. And understanding which ones are good for you and which ones are bad and in what context. There's just a world of biology out there that was very hard to get a hold of, very hard to measure, but now we have tools that allow us to do that. So we're trying to aim all of that technology now at what's underneath the water here, the submerged part of the iceberg of Alzheimer's disease and related disorders. And we have this program called Clear AD that's trying to link what's in the brain to what we can measure in blood and elsewhere in the periphery. And we've set up some hypotheses with those 25 pathways. So the ones that are in the middle there, the core of this thing, are cerebrovascular, which you've heard a lot about today, the immune system and inflammation, immune dysregulation is another critical one that's a very big topic here in Kentucky for investigators. Myelination, which is critical for the white matter fiber tracts of the brain, and for neural transmission, and then synaptic integrity as well, as mentioned earlier. And then all of the other pathways. So we're not going to ignore any of them, but we prioritize. Sort of like you look at the ones with, as Dr. Abner would say, where there's the most evidence, and then you go for that first, and then you go for the other things, and eventually we leave no stone unturned and look at everything. But we do it in order. So what we want to find out is with the gazillion correlations that one can do of all this, and you can get totally lost in this giant hairball of correlations. Instead, what we want to do is figure out what is actually driving. What is driving the plaques and the tangles, the amyloid and the tau in the first place? And it may not be the same in everybody. So that's where the precision medicine part comes in. So we want to individualize our knowledge of the drivers. If it turns out the data eventually show it's the same in everybody, I don't think that's going to be the case, but if it did, great. We can have a blockbuster drug and we could put something in the water, we'll all be fine, you know? But likely we are going to need the precision and have things fine-tuned for each individual. So just to kind of like, where's this all going? Well, with the mass of data, these thousands and thousands of data points, we are going to need to exploit artificial intelligence, deep learning, and other advanced strategies. So have the good fortune to be part of a consortium called AI for AD for short. I think it's the greatest name for a grant. Artificial Intelligence for Alzheimer's Disease, from people from many institutions involved, all collaborating together on this using the latest techniques. I'm going to just show you a couple of examples of how you can apply deep learning tools. So at IU, Dr. Tejo Joe in my center is using deep learning to look at tau PET scans to find what are the most, where you have thousands and thousands of little dots or voxels in these scans, which ones are most important, and is there a pattern that emerges that's most important for separating Alzheimer's disease from cognitively normal controls? So those are shown on the right, and I'm not going to go through the details of this, but here you see a conventional statistical analysis showing these temporal lobe regions with lots of tau. And then here you see what the artificial intelligence strategy says are the most discriminative places in the brain where the tau matters the most, which is pretty much focused around something called the entorhinal cortex deep in the temporal lobes. We know AD pathology starts in those regions very early on. Another strategy Dr. Joe and some of our other team members have been working on is developing a tool to go through the 3 billion bases in the genome and try to find the genetic signals that are most informative, because we need search strategies to go through that much data. So we have something called a sliding window association test, or SWAT, that uses deep learning to slide through the genome and try to find the key features. And then we compare it to the conventional statistical approaches. And here's where, this is my cartoon of like, how do we put all this together, right? So the goal is to take the biomarkers, the healthcare data, clinical data, cognitive data, everything we have, and then profile the individual and develop a therapeutic strategy. Again, it's aspirational, it's a vision. We don't have this shot to administer today, but the concept is to understand what's the person's profile for amyloid, for tau, for immune system regulation. Is it too hot, too cold, inflammatory, not enough stimulation to clear plaques and tangles and so on? What about diet and the microbiome, liver, the gut? Lifestyle factors that we heard a lot about earlier. All of these things need to be profiled for the individual and the treatment strategy tailored to that person with the right timing. So here's where we are. This is the road toward precision medicine for Alzheimer's disease. Well, we had no disease modifying therapy. Now we are in the era of disease modification with amyloid clearing therapies, of which you heard there are 2 approved. The next thing is, what about combinations? So you just heard about 25 pathways. Well, and 4 that we prioritized. Which ones, what do you administer next, right? So if you knock down amyloid, okay, do you then try to target tau next? That's a big hypothesis out there. Anti-inflammatory strategies and immune regulation therapeutics, another really big one. There are lots of others. There's another paper, I didn't put that figure in, with like 150 different drugs in the therapeutic pipeline from, from early stage preclinical work to late stage clinical trials, all that target many of these different pathways. So if we were over preoccupied with amyloid, now it's all on the table and we're looking at everything, no stone unturned. So I think we are going to get there. We're going to have combinations, novel pathways, and eventually we will get to that precision medicine. It takes volunteers and it takes a team, multidisciplinary team. This is our counterparts of the wonderful team here in Kentucky. Dr. Schneider's wonderful team, who I know well at Rush as well. This is on the left is the Indiana ADRC group. And then we have a community advisory board, like many of the folks here, many of whom participate in our studies, who guide us and also help us with understanding different communities that are understudied historically as well. And have been just a wonderful source for us of inspiration and support. And also, there's this vast network of collaborations from all these different NIA and Alzheimer's associated funded grants and all kinds of other supports that let people collaborate scientifically from across the country and around the world, really, all working together. And we're privileged to be a part of many of these studies, leading and co-leading some, but a team member for many. And it's a great landscape, I think, working together with collaboratively with open science, sharing data, and working as a field together. We're going to get there, and we will have a precision medicine in the future. So it's been a privilege speaking with you, and looking forward to the panel discussion.
Okay, we're going to transition to the panel discussion. So can I please ask all the speakers, as well as Sarah Hatch, who is one of our social workers, to come up. While they're coming up to the stage, I just want to let you know that we are recording these presentations and they'll be on YouTube. So eventually, when we get it, we'll put it on our website. So you guys, we'll put a link where you can download the YouTube. So if you want to revisit any of the talks you heard today, you'll be able to. Should also say that our moderators for the panel discussion are 2 of our Sanders Brown faculty, Steve Estes and Dan Lee. Don't want to forget that.
Wonderful. Thank you. And so, and then Sarah Hatch is a social worker there at the end, part of the Sanders Brown cohort as well. So there you go. And so we really appreciate the many questions that we received. And so what we're going to do here is we're going to try to ask the questions we think have the widest appeal, the widest interest among the group. If you do have questions that are more specific to you and your situation, our speakers will stay for afterwards to answer some of those and try to talk with you. So after this session concludes, Dr. Van Eldik will say a few moments of so long. And but then our speakers, if you would stay up for a few minutes. So let's go ahead and get started. So We heard from Dr. Saykin there in particular about the benefits of using AI, artificial intelligence, to as a research tool to better understand this plethora of data we have. But also had a really nice question about what's the role of AI in some of the Facebook, whatnot, advertisements going around for things like herbal supplements, because some of those are clearly hoaxes, they're fakes. People are using AI to marketing, and so how can the audience as consumers, as interested family members, how can they know which things might be useful and which things are not? And so that's just a general question for our panel. See what people have to say.
So I would say that, you know, powerful tools can be used for good or they can be used for other things. There are a lot of so-called deep fakes out there. I've seen some of these myself where there's a prominent physician who appears to be promoting some product, and they basically just through AI attach their head to somebody else and are putting words in their mouth. It's really terrible. I mean, it's hard to sort these things out. So you have to go to reliable sources. Don't believe anything that you see that's out there. You have to double check. And I would say a good source of trustworthy information is the Alzheimer's Association website. But certainly, you know, also talk to your physician or health provider if that's a concern. But you should be skeptical of anything you see that's being advertised out there.
Yeah, I'll back that up 100%. You know, some dramatic claims, there's something that we have in medicine as well that we call the Lazarus effect. If it sounds too good to be true, if somebody rose from the dead, it's probably not true in general. So always be skeptical. And you have to figure, you know, for some of these, you know, our computer program is going to completely, you know, help you. Our supplement is going to completely eliminate your future risk for Alzheimer's. If that were true, it would be on the cover of the Wall Street Journal, the New York Times, the Herald Leader here in town, and on every major television network. So you can also use that test. Look, as kind of Dr. Abner pointed to, look for your information in multiple sources. See if it's repeatable or if you're just getting a bias slant.
Yes, I'll just add in that probably one of the most common questions I get is about those TV ads on Premagen and Nuraviva or whatever they're all called. You know, I think my sister even contacted me, should I be taking this? And the truth is, a lot of these supplements don't go through the rigors of a clinical trial like that we use as physicians. So they make claims that don't have to be verified through science. It doesn't mean they don't work, but it doesn't mean they do work. So it's very difficult for us as physicians to know what to recommend. Usually I get very nervous when it's something that's not water soluble that I think can be accumulated. And I do warn people, if it says 1,000% of a daily allowance of something, that's a lot. But the answer is we often just don't know unless it's been through rigorous clinical trials.
Yeah, so that adds to a lot of the questions about supplements. There's a lot of questions about supplements. And so they've kind of asked and pointed on that. One of the things that came up was the role of sugar, the link between sugar and dementia. So could you?
Yes, I can speak a little bit to some of that because we do a lot of dietary studies. I think that other people here do too. So there is a literature on diet for sure. And there are studies that have come out that shows high sugar diets to be bad for your health. So we've certainly seen those studies. I don't think that there's been recommendations per se yet about that specifically for Alzheimer's disease, but high sugars known to be bad for a lot of health conditions. It's kind of like saying, should I have high salt diet, high sugar diet, high cholesterol diet, eat a lot of red meat? I mean, I think we've heard these things over and over again for our heart health and our general health. So I think some of it's common sense that some of this stuff isn't good for you, but the answer is that we're still learning more about diet and how it's affecting and the individual vitamins. So when I first started, there was a study in vitamin E where we started giving out vitamin E all the time to our patients. And then it turned out that it wasn't as good as we thought it was. And the most important thing I was ever told by nutritional epidemiologist, Dr. Martha Claire Morris, who created the Mind Diet, was it's best to get these things from your food, without question. And the studies are very hard to do with supplements because people start taking supplements when they don't feel good. And so when we have our studies and then we look at people who take supplements, it's all messy because we don't know why they're taking it. And so supplements are just very difficult to get a handle on. And my advice would be to eat the right foods to get those vitamins. That's the best thing that you can do. You'll probably hear it in the New York Times before me or the Washington Post or whatever you read, Wall Street Journal, if there is something that really, really is going to work.
I'll just give a quick vignette. When we started a series of studies on metabolomics and Alzheimer's disease, one of the first things we did was look at people's medication history and supplements and so on. When people were taking fish oil, very common, we saw this huge spike in lipids and we could measure it. So, you know, the things that you take in actually do affect your physiology. And with some of those omics that I was describing earlier, you can actually detect these things. There's big effects, but they may not necessarily be in the direction that you hope they would.
Yeah, I just wanted to chime in on the sugar issue. I think that Dr. Schneider really hit the nail on the head when you think about this. Think about your vascular risk. She showed us in the pathology what a major driver vascular disease is. And diabetes, high sugar levels, high glucose levels in your blood are a driver of that pathology. So in general, you do want to keep things in moderation, not 1,000% of your daily allowance of sugar. Anyway, but we did actually look in our cohort several years ago at grams of refined sugar consumption and whether or not there was a relationship to memory and thinking. And actually, we did not find the same kind of association that you see in school children that are on high sugar diets. The amount of weekly sugar consumption did not seem to immediately affect your memory and thinking test performance. We presented that at a national conference. The title of the poster, "Go ahead and have that extra donut."
Yeah, so another one was about metabolic syndrome and how that kind of affects it. So if you guys have kind of touched on that, but is there a direct link or an indirect link between the metabolic syndrome in AD or obesity or something?
So I think, again, it's a vascular link, right? We have done many studies of metabolic syndrome and cognitive function, dementia risk, things like that. The magnitude of association is not huge, which means I'm not saying like somebody with metabolic syndrome doesn't have 10 times the risk of Alzheimer's disease, for example, or vascular dementia, but it does all contribute. So I think I saw a slide in Dr. Schneider's talk with the phrase heart health is brain health. And so if that message can stay with you, the things that are good for your heart. And so not having metabolic syndrome is good for your heart. So having metabolic syndrome is causing some additional burden, right, on your cardiovascular and cerebrovascular health. So that's really the link that we're thinking about are your blood vessels in your brain.
Okay. So social workers, we've kind of already given Sarah a round of applause there, but Sarah, would you talk about the role of social workers and the process of what's your role in the Alzheimer's Center?
Yeah. So part of it is education about resources. What are the trustworthy resources to go to? We talk a lot about brain health, and heart health is brain health. That's one of the things that we talk about as well. And then we come along, our participants, and provide support. So we help make connections to local resources, make connections in social or support groups. We do socialization groups like Memory Cafe, where we can come and have fun together because we know socialization is such an important thing. And that as the disease progresses, caregivers and people with the disease kind of start to lose that socialization. So we really try to wrap around participants and their caregivers and provide support, knowledge, information, and connections any way that we can.
So and I'll just plug for our social work team, especially Sarah here. I put together a program called Brain Health Activities. There's a flyer in your Markesbery Symposium. It is activities for people with mild memory problems, activities for people with more advanced Alzheimer's disease, and that has been accessed by and has helped tens of thousands, over 50,000 people. Within the first few months of its release a little over a year ago. And she's currently helping to lead a project along with April and some of the others here, what we call the Care Compass, which are hands-on training that can be accessed virtually anywhere in the world for patients with late-stage Alzheimer's. How do we help our loved one who may not be able to speak or walk any longer still maximize their quality of life? I'm really excited about that program as well, and I can't wait until it's released. Probably early release this January as it continues to build over time. So as Rachel Maddow says, watch this space. And great job, Sarah, and all of the social workers in the community.
Okay. So there's a couple of questions on if you are amyloid positive for PET or biomarkers, what are the next steps? What are the type of tests that you can get via blood, CSF, PET scan? Who would be a good candidate? What is typically the next steps if you come up positive for one of these types of biomarkers?
You know, I'll just chime in on that. I see a lot of this in our clinic locally with the advent of these new blood tests that Dr. Saykin and Schneider talked about earlier. There's a lot of accessibility, and people are out there, and a lot of private practice doctors are just screening people that are completely normal in their memory and thinking, and then they're getting back a positive blood test, and all of a sudden it's a freak out scenario. And so they're being sent over of what do we do? What do we do? And the first thing is, you know, and I think that was very nicely pointed out earlier, is that the blood test cannot tell you if you definitively have Alzheimer's disease. The FDA approvals are for you do not have Alzheimer's disease. They can be very reassuring, but we do not advise these blood tests to be used as of yet, because we have nothing we can do as of yet. The studies are waiting. We only use the blood test as a screen. If somebody comes up positive with a blood test, then that needs to be followed. If they're having memory problems, they needs to be followed up with a spinal fluid or amyloid PET test that can actually diagnose, not just exclude a diagnosis. So really, really important. And from there, we start working on a therapeutic strategy as personal as we can get these days. Just caution about everybody in the world getting an Alzheimer blood test. We're not there yet.
So COVID has certainly been I assume everybody at this point, or the vast majority of us, has had COVID. And certainly we probably know people that have had long COVID and the brain fog that goes with that. And so the question here is, how does COVID, long COVID, influence the risk of dementia and Alzheimer's disease?
I don't think we know yet. I'll just say that, it's one of the things that we're trying to figure out in many centers around the globe. Erin, I don't know, are you familiar? Is there any literature out there in the epidemiologic world?
There's some studies that have shown, increased levels of amyloid in the brains of people with long COVID relative to other people their age. But it just hasn't been long enough for us to know. I think we're probably comfortable saying there's not like an immediate transition in most people who get long COVID, like dementia is not immediately on the horizon. I don't think there's any reason to suspect that at this point. But in terms of how it truly affects our brain health over the long term, we don't know.
I'm sure Dr. Van Eldik would love to hypothesize that it's all due to the brain inflammation induced by COVID.
I will say that we did do a pathology study looking at some people who died with COVID, and certainly there is inflammation in the brain with COVID. So I think one of the hypotheses would be that there's a continuation of that inflammation in some way or form.
There is a fair amount of research going on trying to look at this and look at genetic risk for COVID and Alzheimer's disease and readouts on various biomarkers, but I don't think any of it's shown anything definitive yet. But work's being done. I think we'll get answers. And all of the Alzheimer's centers implemented a COVID self-report screening as part of the common assessment that we do across all the centers. Some of us, just 4 centers, are involved in a small pilot, kind of a proof of concept study to integrate genomic data, all the data collected for cognitive and neuropsychological testing and everything, and integrate that even with healthcare outcome data from the Center for Medicare Medicaid services, and pull all that together in a secure enclave that the National Institute on Aging manages. But it's still very early and the numbers are still fairly small. So I think that follow-up is going to be important. We're going to learn something about the relationship, if any, but we're not there yet.
And my guess is the multi-omics approach is what's probably going to be needed in the future to answer that question. So great work, Andy.
Just one last comment on the COVID issue. From my work in clinical trials that we conduct at the center and reviewing adverse event data, I think the greatest risk of COVID among the older adult population is still death. We are still having research participants get COVID, get pneumonia, and just have an absolute failure, respiratory failure, never recover. You don't want COVID. If you've had COVID, you don't want it again. If you've never had it, you don't want it. So do consider taking those precautions, right? For keeping yourself free from COVID infection. It's not a neutral. It is a bad thing still.
Thank you. So Dr. Schneider mentioned this new disease that you've come across called with TDP-43 pathology called late. Is there a diagnosis for late, or are there any clinical trials going on for late, or are there any biomarkers with this type of disease?
Well, I am so excited to say that the first clinical trial for late was done here at University of Kentucky. So I am going to let Dr. Jicha talk about that.
The trial's still underway. It is something that I did in collaboration with Pete Nelson. I will say as well, there is, one of the references was on Dr. Schneider's slide deck. There is just published this year a clinical consensus criteria. The first, it's going to need to be refined as we've done with Alzheimer's diagnoses over time. But there is clinical criteria out there that can be used to predict probabilities, possible late, probable late. We can't definitively diagnose it until autopsy. Next year, I suspect, though, the first trial of late, we will have the results, I suspect, potentially by the time of Markesbery Symposium next year. And I've been thinking about presenting those at the clinical trial in Alzheimer's disease in later November or December. But I think it would be a real treat for our community, for you all before the rest of the world. Here's the results, to hear it right here first. So we'll really be shooting for that target.
Yeah, so very, very exciting research, and I think super important research.
So there's another question here. The next question is, so people, if they do contact the Alzheimer's Center, and there'll probably be a rush after this symposium, but how long should people wait for a call back, or what's the anticipation in terms of callback and in response to people reaching out?
You know, this in the past has varied. And so if there's anyone out there that has contacted us to try to get involved with research that has not had an immediate response or follow up on it, we really recognize this. And one of the things that we've done that's part of the Be Bright program, as well as our central longitudinal cohort and all of our affiliated studies, is we've begun to automate this system so that we can personalize education, research opportunities, and this really is going to be real time. So you undergo a memory and thinking test if you're part of Be Bright, likely within the next day, if not hour, you may start receiving information and feedback that instantaneously. In the longitudinal cohort, we have more to do. We have blood tests that need to be analyzed, MRIs. We're working right now to try to see if we can get to a feedback within 2 months. But if you're not getting a response, call us back. But we hope to have that electronic system up and fully operational within the next week or so. As a matter of fact, we've been pushing for Markesbery Symposium so that after this event, we're going to be able to take your registration information and within the next week really start being responsive to any questions we don't answer in the panel today, other resources that you may need, other opportunities for engagement. It really is a priority for us.
Okay, so some of the audience was kind of interested in expanding or explaining a little bit more about that extension through Clarity or some of the immunotherapies, and how does that, or is the amyloid therapies, does that have any type of an effect on tau and tau PET? Is there any relationship between the amyloid therapies and the tau?
Yeah, I could start if you're tired of talking.
So I want to get a diversity of opinions.
Yeah, so that's really the $1 million question, because we think that amyloid deposits and then tau comes a little bit later, and that's really toxic for your memory. This widespread tau accumulation that we see in Alzheimer's disease. So the initial studies showed some positive signal. My understanding, and you can correct me if I'm wrong, was that there was some reduction in tau. I'm not sure if it was published with the actual article or not. So we're encouraged. There's encouraging data suggesting that there's less tau in the brain, but we need the follow-up studies still. And we just don't know yet enough. And the question won't only be, is it helping, but does it continue to keep the tau lower than we otherwise would be, to keep that trajectory so you're not getting as impaired as fast? So something very much of interest. And there's also tau agents being worked on, because maybe you need something against amyloid, and then maybe you need something followed up against this other abnormal protein. So all of that is very, very topical right now.
Yeah. I think that word of caution, again, with those prelim results, they really come from subsets of people that have had tau PET scans, or subsets of people that have had spinal fluid, or they come from tau measures in blood, which actually most of those assays are more related. It's a tau measure, but it actually tells you more about amyloid than it tells you about tau in the brain. So we really need that data replicated. We really need to understand it. We don't want to go down that rabbit hole. But it's also possible that there are other consequences of removing amyloid that equally need to be explored. There is a modulation of the immune system and the inflammatory cascade of the brain. So there's a lot yet to understand, and that data will be coming out. It's nice that we have 2 agents approved, because we can start to look what's coming in from each pipeline. And wherever we find areas of agreement, that will strengthen our confidence that this is something that truly needs to be explored and is worthy of exploration.
All right, so we're running out of time. We're going to try to rapid fire this one. What are your thoughts on statins in relation to memory loss? And possibly, I'm going to throw another one in here. If the role of depression, does that help with resilience, or does it have any effect or relationship? So.
So in terms of statins, I take one every morning.
Yeah, no, I don't have anything. I don't have it on statins. I mean, I'll just talk about depression. I think depression has been considered a risk factor for Alzheimer's disease for quite a while. There's always been a little bit of chicken versus egg. Sometimes people who initially have cognitive impairment look depressed to their family. They look apathetic. They look like they don't enjoy doing things anymore. And sometimes as physicians will start people on antidepressants thinking, oh, they're just, this might be depression and not cognitive impairment that they're having. So there's been a little bit of controversy about that. I think it's withstood the test of time, that it does appear to be a risk factor, but people are still sorting out how much is within the disease trajectory. And when you start having symptoms of memory loss, how much depression can that cause also? So disentangling this is still difficult, but I think important.
Yeah, I agree with that. And there's a fair amount of research going on looking at Alzheimer's biomarkers in depressed cohorts, especially late life depression. And then there are lots of studies that are more Alzheimer's disease detection and follow-up oriented that also measured mood. And my reading is the results are really kind of mixed. Some find associations with amyloid or tau or other biomarkers, and a lot of the studies don't. And then it becomes a matter of what was the design, how were people selected, and other criteria. So I don't think we really know for sure yet. There's a review is on one of my slides, and if those are made available, I mean it just in the last year in Nature Mental Health, it kind of goes through the literature on this.
Now I'll just add
Yeah,
one point to what you're saying. If you look at our studies, we've had a lot of interest in depression, and we see no relationship between depression, amyloid, and tangles. If there's some relationship with depression, we think it's working through some other route in the brain. We do not see a relationship with amyloid and tangles. I know others might have.
Possibly lowering resilience, maybe.
That's what we think. Yes, yes.
We're right up against the top of the hour, and there are more questions. I wish we could ask them all, but we're really just running out of time. So if you do have questions you'd like to ask, please come up and approach our panel after Linda wraps it up.
I'd like to thank the panel for
Linda, yeah.
All right. Well, my closing remarks are always very short, so we'll be out of here in a minute. But I just really want to thank everybody that came today. I want to thank everybody for their questions and for your interest. I think our speakers were wonderful. I want to thank all of them for the presentations today. And I want to thank everybody who put this program on and did all the work to make it happen. Sanders Brown faculty, Sanders Brown trainees, Sanders Brown staff. They're wonderful. I couldn't do this without you guys, so I really appreciate it. And be sure to turn in your little blue things here so you can get your parking and you can tell us what we want to do better next year. So thank you guys for coming.